to go over the number systems. This always seems to confuse students in general because of the different classifications. So I made this little flash animation of fish eating fish. So let me explain it as I go. I'll start this over. Let's flash it over. And okay. So first, I have the natural numbers. They're like what you count on your finger. 1, 2, 3, 4, and maybe you start with your toes. And we would call them natural because, well, I don't know, they're natural. And then I got these hooks. That's to go forward, you see. So now I have this big one that's called the whole numbers. Now, this means at 8, the natural numbers. So what you got of the natural numbers is really all your natural numbers, but if you throw 0 in there, which is an advanced concept that the Mayans and way before them, the Babylonians, current day Iraq, came up with 0. So, well, let's continue now. So now we know what whole numbers are. They're just the natural number with a 0. Then we have this giant fish. It's called the integers. So you have to imagine this fish ate the other 2 fish. So now you have 0, the natural numbers, and now you throw in the negative numbers. So now you can see that they are negatives up the ladder. You're -5 in the hole, 4, 3, 2, -1. Now you hit ground level at 0, and you go up the ladder 1, 2, 3, 4, something like that. Looks like a catfish on the way. Big giant one. And that one's called the rational numbers. You can see they're getting pretty big. The rational numbers are in a form A divided by B. Well, guess what? 1 is a rational number because it's 1 divided by 1, or 2 divided by 1. They are fractions by definition, and so is -5. -5 divided by 1 is still -5, right? And 0 divided by any number other than 0 is 0. So we can see that a rational number is a much bigger set than the natural or the whole and the integers because it fills in all the numbers in between too, like almost all the numbers, and so you can have a half, for example. So far so good. We're getting a lot of eating going on here. And then I got this freaking, well, it didn't look very good. It's an irrational number. These irrational numbers are truly irrational. They're so irrational that this fish won't eat any of it. Neither this fish eat that or that or the other. It's kind of a class unto itself. You'll have these irrational numbers, like you also in the irrationals you'll have something like the ones like pi, 3.1473, where that also the decimals go forever and ever, and there's no real pattern to be called depending on how far down the decimal line you go. So the golden ratio is another one. So next we got this nice little looking goldfish koi thing coming along. It looks pretty innocent. So, but it's not. It chomps up everything. So this is the true, with this little goldfish or giant goldfish, and that in itself is called the real number system. Alright, hope that helps. Oh, wait a minute. We got this guy, and we show what it is. The snail came in. He's the one that's called the square root of -1. Guess what that is? That we give it a letter called I. Because you can't, what is the square root of -1? Well, square root would be something, -1 times -1 is 1, not -1 again. So that doesn't work as a rule for square root, so we call that the imaginary numbers. Okay, so it turns out that actually the imaginary numbers devours everything, including the real numbers. So that's a snail, I guess, that eats everything. Okay, so the ultimate would be the complex number system. Alright, thanks, hope that helps.